Hello, everybody. Welcome to another installment of what we call Forensic Science in the Basement with your host, Mr. Andraco. Um, I am here to first apologize. The last video did not do a good enough job of explaining all the concepts, and I'm very sorry for that. Usually we do a lab and we go over this a bunch of times, but as I watched that video and got some responses and some emails, I can see that we didn't learn what we needed to learn, and it's totally my fault. So all I can say is to my performance. So what I'm going to do is try to do a quick but thorough review of the necessary points for this section, as well as do a quick blood typing overview. So let's check that out. I hope that you don't get motion sickness as I move you into position. My goal is to try to not cause any distress. Okay, so here we go. The first concept is pretty self-explanatory, right? The harder the surface and less porous the surface is, the less spatter will result, right? Where I dropped materials, or I used different materials to drop the fabric on, and I was at a consistent distance away. And since, of course, the substances have nowhere to go, really, technically, on the tile and the metal, because they are not very porous and hard, and so they retract due to the properties of water, where, say, unsanded wood or cloth would kind of soak in, and there would be a wider spatter. Okay, so that was the comparison there. That one I think you guys all got. The second one we had a little bit of a struggle with was talking about the direction of travel. So, even though when you see a drop of blood falling, it's moving in the opposite direction of these arrows. But when it hits a surface and then the tail end of it keeps moving, it forms a drop that's in the opposite direction. So the usual law is this, but these are showing the direction of travel, because as I did in the videos where we did them from angles, you would see that it hit and then kind of trail off. But this is what we were looking for number 2, when it said draw some blood stains and things like that. Number 3, the impact angle of blood, right? When blood is dropped from a 90-degree angle, you'll get a perfect circle, right? I use this example as if someone's walking who's been injured and you see drops of blood that are perfect circles. You know, you can kind of trail them because they are dripping with blood. But when you see stains that have a length and width to them, they have come from an angle of some sort. And you can actually use trigonometry to do so. So what I did was I made a simple design to use the trig where we've got approximately 2 centimeters at its widest point. This guy is about 6 centimeters in length. So to do the math easy, it's the sine theta of width over length, and I set that up. Now in your calculator, if you do want to do this at home, if you guys are trig or math lovers, you don't have to. You can just set it up like it is here. But if you guys are some math lovers to double check your work, this is how you would put it in, because you have to use the inverse sine. And so for this blood drop, it came from an angle of about 19 degrees. So that's how you would use this concept. The last one a lot of you guys got, right? Once you remembered that the blood is moving in this direction, right? You draw lines backwards from this, from the fat points, right? And you will find the point of origin. So the intersection or the point of convergence of these lines will show that point of origin. So that was the fourth one, okay? All right, so let's see if we can zoom in a little bit here. Okay, so let's talk blood type. And hey, let's talk this beautiful table. I just finished refinishing it, and I'm very proud of it. Okay. Real quick, right? If you have the A antigens and you have the B antibodies in your blood type is A, right? Which would never mix with blood type B, because if you have blood type B, B has B antigens on it and A antibodies traveling in the plasma. So that would be blood type B. And of course, if these two blood types were to come in contact with each other, right, what would happen? Agglutination, where these antibodies would agglutinate with these antibodies. Okay, so that's kind of a protective system. Okay, so that covers your A and B. Let's talk about AB, right? Blood type AB has both A and B antigens, right? And no antibodies. This is why blood type AB is the universal recipient, because it doesn't have those A or B antibodies to react with other blood types. So blood type AB is the universal recipient. Blood type O, of course, people love to brag about being blood type O because they are the universal donor. Why are they the universal donor? Because they have no antigens on their cell surfaces to cause any reactions. But they can only receive from blood type O because they have the A and B antibodies in their blood serum, and so if they receive blood type A or B, that would cause agglutination. The last part, which is controlled by a separate gene and a separate discovery, is the Rh factor, which gives you your positive and negative. For your blood type to be positive, the antigen would be present on your blood. If you were negative, you would find the antibody in your serum. So, quick example. This is my blood type, which is yellow. Antigens are B, and the antibody is present. So my blood type is B negative. Okay, my blood type is B negative, which has the B antigens and also has, of course, the A antibodies in there, as well as to be negative, it has the green Rh antibodies. So that's how you would figure out blood type. So hopefully that helps you guys to understand the table at the top, and then the four concepts that help you with looking at blood spatter and evidence. So, Andraco signing off with all apologies. Hopefully that helps clarify. Let me know if you have any further questions. Andraco out.